This tutorial is all about rigid bodies. To learn about rigid bodies, we have to know first what is a rigid body. So when you say it is a rigid body, it must be a solid body of finite size wherein deformation is not allowed. A deformation, which means change in its original shape. In the image, consider the gray highlighted area to be the rigid body. The red circles are points on the surface of a rigid body. The blue lines indicate the external forces acting on the points or the surface of the rigid body. Now, the simple rule is that something can be considered a rigid body if the points on the surface don't move even when some external forces are applied on them. To continue, let's move on the analysis of kinematics of rigid bodies. When it comes to rigid bodies, you need to understand the three types of motion associated with rigid bodies. First one is called translation. In order to understand translation, observe the figure. It carries the rigid body. Look at the red vertical line. Even if the body has moved to position 2, the vertical red line has remained by the load it exerts. This type of motion is called translation. You can see its essential regions dragging without any ovation. You are just dragging the cylinder along the surface. This is called translation. Next is rotation. Rotation is very well known. You know the ceiling fan? It rotates along the fixed point. This is said to be a rigid body in location. And next is plane motion, which is essentially the combination of rotation and translation. The cylinder. Let's move it from position 1 to position 2. Let's see what happens this time. The vertical red line has become horizontal. It means that the cylinder has translated and also rotated at the same time. That's why its vertical red line has become horizontal. That is why it is said to be the combination of the two other motions introduced earlier. Our objective for this tutorial is very specific. After this, you should have the capability of finding the velocity of the rigid body in motion, knowing velocity of given reference point. You will always be given a velocity in a reference point, and you need to find the velocity of the object at any other point. For that, let me give you important notes to be considered. Let's say for translation, I have a cylinder with a reference point whose velocity is to be taken as the center itself. It can be at any point, but for this one, I'll consider the center and let it be 5 meters per second. As the cylinder moves, velocity of the center can still be 5 meters per second. Let me find the velocity of the top point. It is also 5 minutes per second. The motion is just translated. Also, the center and the top point is rigidly connected, so there is no need for any change or velocity change. In fact, when a rigid body is in translation, all the point on the rigid body has the same velocity as the reference point. In that, we could say that studying the motion of rigid body in translation is very simple. It's almost like treating a body like look at particle. Next is rotation. Rotation is rigid body that rotates about some reference point. Circular motion. So from your knowledge of you already know that velocity of a point will be r omega. If you were to find the velocity of points in circumference as shown, all of them will be r omega and different points. I'm assuming the rotation to be clockwise. First, I need to know a velocity of any point, and then draw a concentric circle with its velocity. That will be r1 omega. If that's so, you will find the velocity in any point on a rigid body. And lastly, the plane motion. Let's say this cylinder is in plane motion. Its centered velocity, which is given as 5 meters per second, and let's also assume that the angular velocity of this cylinder is y in a circular plane. Now, let's see the second position of the cylinder. Its center velocity of 5 meters per second is needed in finding the velocity of a point in the circumference. Now, this point must have a perimeter per second base point on the circumference. But this is not the end of the story, because in addition to translation, it also rotates. So due to rotation, that point will have the velocity of r omega, wherein r is the radius and omega is the angular velocity of the point. So together, there is the white arrowed velocity together with the previously given velocity. This aspect of two velocities and combining them can be clearly explained if you were taken actual examples. Now let me take a cylinder which is in plane motion that is translating and rotating. We have here the reference point with velocity of 1.5 meter per second, the point from the circumference, and the reference point is 0.75 meter, and this is rotating in 2 radians per second. Now, we will find velocity of any other point in this cylinder using those data. For example, we will find the velocity of the point which is coming on this circumference of this cylinder. Because the reference point and this point is rigidly connected, it will surely be that one of the velocity of this point is 1.5, which is the white velocity. There is another velocity here. This is done because while moving, cylinder is rotated with 2 radians per second. This is in downward direction because the cylinder is rotating clockwise. The white velocity is the translational velocity, and the red one is the rotational velocity. Now let's take another velocity in the bottom part of this cylinder. Our red velocity will now point on the left because because of the clockwise rotation and still its velocity be 1.5 meter per second since it is rigidly connected on the reference point. Then the right one be pointing at right, and because of it, the net effect of this velocity will be 0, and since that point touches the ground. We will take another point. The red arrow now will point upward because of the clockwise direction, and its velocity still be 1.5 meter per second, while the white arrow be pointing on the right with velocity of 1.5 meter per second, the same reason I told you a while ago. Now, let's take the top point. Similarly, the velocity of the two arrows are both 1.5 meter per second, and they will be both pointing on the right now. Let's move on taking some point in between the cylinder. This will measure 0.6 meter from the reference point. Our translational velocity will still be 1.5 meter per second, but the rotational velocity will be computed as r1 omega. So 0.6 multiplied by 2 is equal to 1.2, and the rotational velocity now is 1.2 meter per second. So that is how we take the velocities of point in plane motion of a cylinder or the rigid body. Always remember that there is two velocities, the rotational and the translational velocity. That there were three types of motion in rigid bodies: the translational, rotational, and plane motion. And for that, thank you for listening.